Hello and welcome back, my fellow game developer enthusiasts. So, in this video we're going to be going over arrays, so that way we can have modular functionality within our game objects. Now, all an array is basically a bunch of variables grouped together. It's technically one variable, but this is the best way to think of it. Now, in a literal sense, when you have, say for example, integer a, it can be pulled from any location in the RAM. And if you had integer b, it could be pulled from any other random location. There's no guarantee that they're right next to each other. What an array is, however, is that it is a group of variables that are right next to each other. So let's say we had three variables called x, which can resemble the x value, the x coordinate of three different balls, right? So essentially, this array holds three different values. Each index, let's say this specific spot in the RAM, this address is the 50th address, right? And in order to find the x of the second ball, we would basically go up an integer's worth, which is 4 bytes, which so it'd be like 50 plus 4, 54. And then 54 plus 4 would be 58. So it's a way to sort of iterate through. And because the data is so close together, we can just simply iterate through it instead of having like a file with like x1, x2, x3, x4, x all the way until you reach how many balls you want. And it's a nice way to sort of not only simplify your code, but to make it more efficient as well. Now, the simplifying part I can't really explain until we actually get down into doing it. But because of this, because of the fact that we can group variables together, we can iterate over them and deal with them much more efficiently. So just remember that all an array is a bunch of variables grouped together, and they're individual variables that you treated all within one sort of capsule. So you know this capsule, like you could call it ball x, would resemble all the x values of each and every individual ball. And so in order to get the x that you want, you would have each of your balls indexed. So there would be like the first ball, the second ball, the third ball, and you would take the number of the ball that you created and then get the x from there. So so I'm going to show you directly in code exactly what I mean. Alright, so in here, like I said before, excuse me, we are going to create an array, call it int, I'll just say int x for the heck of it. I would say ball x, but I guess x is good enough. So int x equal, so yeah, this is basically how you declare an array. It's different in C++ than it is in JavaScript. I should go ahead and note that. But sort of just like this is technically a dynamic array. I'd rather show you the static array first, but oh well, don't worry about it. Just know that when you see these brackets here, just know that it means an array. So we're creating an x array, and in our setup function, we would do something like x equals, I don't know, x equals x. No, I'm sorry, what am I doing? Okay, so the x array gets new int, and here's where we can decide how big we want it to be. So basically, we want a certain number of balls. So I would say like, I would actually want to create another variable to hold the amount of balls. Ball count. And I'll give it the value of like 10. So basically, hold on, why is it because I have to do this? Oh, there we go. Okay, so first thing we're doing is we're creating a variable called ball count, which we can use that to reference later to know how many balls we're creating. So that way when we change this, the rest of our code changes with it. So we're creating an integer array named x. And inside of our setup, we're saying x equals new array with size ball count, which up here is 10. So we're creating an array of 10 indexes, which means we can hold 10 x values for different balls. x coordinates. So, with this, and because I feel like doing it anyway, I'm going to make a corresponding y array, int y equals new int ball count. Alright, and remember the setup function only runs once, so this is basically a way of finishing creating our array, more or less. We're just sort of declaring that exists up here, and then in here we're actually like giving it an initial set, or like we're actually creating it, more or less. Anyway, so in our draw function, we are going to use a for loop, like I showed you in the last tutorial. Int I equals 0, I is less than ball count, I plus plus. And then we're going to, oops, I forgot the equals, my bad. Actually, I'm going to copy this. I'm going to stick it up here. I just realized I want to give our balls an initial value. An initial set of values. Excuse me. So, in order to do this, we simply say x, so the x value, or the x array. Inside of here, we're going to give it, well, if we want it like in the last video, yeah, I'll just keep, yeah, if we want it to be like in the last video where we have like a line of balls initially, I'll make this x, basically I times 20. Oh, no, wait. Okay, actually, let me type this out first, and then I'll explain. So, I times 20, there we go. So what this is doing right here is that this is going inside of our x array by index of I. I starts at 0, so we're going to the 0th index. Like, remember how I hinted at the last tutorial that that indexes and arrays start at 0? Well, to explain this now, basically, when you create arrays, and like how I showed you in the Paint program, you do so by basically grouping variables together. Now, in order to reference a specific variable within that group, you go by an offset. So the first value of an array is at offset 0. The second value of an array is at offset 1, and so and so and so. So the offsets are basically like adding an address to the base address of the array. So if we added, well, 0 plus anything is still the original value, but if we wanted like the 5th index, we would add +4 to the base address, and then we would get the specific variable we wanted. So anyway, so out of this, I'm going to make our y's basically all the same, much like in the last video. So again, our x array is, actually, let me run this one step at a time so that it makes sense. So our for loop is created, we get int I equals 0, I is less than ball count, that's our condition, and then I increments each step. So basically we start at 0, so we say, okay, x array at the 0th index equals 0 times 20, which is 0, and then basically all the y's are 20 of the, so give the 0 index of y 20, and then it loops through again. I becomes 1, so x at the 1th index, which is the second index, actually, not the first, the second, because we start at 0. So there, we give it I, which is 1 times 20, which would become 20, and so on and so on. And we do this until we are less than ball count. Because we are starting at 0, we want to make sure that we end up less than ball count, which is like 10. So we want to get 0 through 9. If we got 0 through 10, that would be 11 values, not 10. So because we start at 0, we have to go from like 0 to 9. So That's why in for loops you often see the less than sign rather than like a less than or equal to. Anyway, so iterating through this, we eventually create our nice array here. And to display it, oh, what am I doing? There we go. To display it, we are just simply drawing our values. So y and 20 by 20. Oops, sorry. There we go. Now we should see it working. There we go. See? We have, oops, sorry. We have 10 ellipses starting at, all at location 20, because in our for loop we basically made all of the y integers within our array to be the value 20, so that makes sense. And then the x, each time we are iterating through this loop, we are taking the I and then taking that times 20, which explains why these are spaced apart like this. So yeah, and so when we reference arrays and for loops to basically draw ellipses, sorry, basically down here, all we have to do is this. Basically say, okay, for I equals 0, I is less than ball count, I plus plus, ellipse, and then basically draw at the index that we are referencing in here. Yeah, draw the, like, go through the arrays and then take the index that we are inside of this for loop. So remember how I said earlier that each ball is basically like its own number? Well, this is what I mean. Because we have 10 balls, we start from ball 0 to ball 9. Now, there is an object-oriented style to doing this that makes this loads easier, but I'm showing you this way first. That way, when we get into that, it'll make more sense. So yeah, here we go. So now, if we wanted each of our balls to have their own functionality, we would do so. I mean, like, you know what? Let me just give an example. So in setup, notice how we created all of our balls and they're somewhat predictable. What if I wanted to change the value of a single ball? Now, if we did this, knowing only what we knew in the last video and the videos before, we could not do this. We couldn't really do this and have it work coherently within a for loop. It just wouldn't happen. Unless we had like one individual variable for each and every one of them. But like I said earlier, you would need like 10 variables or however many as you have of the balls. And that would make your code extraordinarily long. So if I wanted to change the value of, say, like a y value of one of these balls, so I'll go to the fourth index, or index 4, equals 30. Why not? There we go. Let's see what happens. See? That one ball right there is different than all the other balls, even though that inside of this for loop down here, we are drawing them all as though, you know, within a coherent pattern. It's just very short and very easy to do. And in fact, it is easier on the CPU to do it this way anyway. Now, now, if we were to really show off that these are individual entities, the best way to do this is to have a physics towards this, like what we did in an earlier video where we had the ball collide with the bottom part and top part of the window, right? So, I could grab code from that example and copy paste, but you know what? It's always good to type stuff out again. So, we are going to create a new function, and we are going to use this function to more or less change the value, the y value of each and every individual ball. So, void bounce. Why not? Hopefully I spelled that right. You know what? I'm just going to call it collide because I'm not sure if that's right. If that's correct spelling. Anyway, so what this will do is it'll iterate through our, again, we're using another for loop. Remember how I said these are common? Equals 0, I is less than ball count. Notice how the ball count's becoming very helpful because within each of our for loops we reference this. So if we change this to 20, it'll act the same. Anyway, and then I plus plus, so I get its old value plus 1. And in here, what we're going to do is say if y to the index of I is less than, is it less than or greater than? No, greater than or equal to, actually we're going to say plus 10, because that's the bottom of our ball, is greater than or equal to the bottom part of our window, so height. Remember I mentioned in the previous tutorial that height basically means it's the same value as the bottom of our window. So that, so if that, alright, so I need to create a new variable, speed y. And I'll do it down there. Yet again, we're going to need more arrays. So each ball we want to have its own speed, so which is why we are going to actually create a new array. Because we don't want to change the speed of all the balls, we only want to change it on some of them. So speed I, speed y, index of I, speed y, index of I. This is quickly becoming complex, but just bear with it for a little bit. When we get into object-oriented programming, I guarantee this will be a lot cleaner. Oh, my apologies. We want the speed y, index of I, to equal, we'll say 3. Why not? Alright. Perfect. And to top it all off, let's say speed y, index of I, plus, which is exactly like saying speed y, index of I, gets its old value plus 1. So, like I said earlier, plus, quite common to see. Incrementing is very, very common in programming. So anyway. Oh, wait. I think I made 2 mistakes, actually. Oh, yes, I did. In fact, one is that this is supposed to equal new int, because we still haven't initialized it yet. We declared it, but we haven't initialized it, so ball count. Okay, now we've initialized it. On top of this, yeah, I made a boo-boo. This doesn't make sense. What we should say is the index of y gets its old value plus speed y. So basically, this ball's y gets its old value plus this ball's speed. So remember, each index is like its own individual ball, so it's only affecting itself. And I made a boo-boo somewhere else. Alright, let's see. If... oh, that should be less than... yeah, greater than or equal to height. Speed y equals negative speed y. Oh! I made a simple error that I've described in our last video. Or actually not last one, but the one before that. So when we create a function, we've basically declared it, but we haven't actually called it. So, yes. So I'm going to go ahead and call it. What's it called again? Collide. There we go. And look at that! It works perfectly. Each ball is its own sentient thing. So when we change one, it's not going to change all the others. So now we have a way to create game objects that behave on their own and that aren't weirdly attached to each other. So now we have a way to manipulate individual game objects very easily with few lines of code. Now, this does look like a lot, I know, but it could be a hell of a lot more if you did it one variable at a time, and then the fact that if you were to scale this up to, say, like 100, it would require even more code, whereas up here, if we replace that with 100, look at that. That's all we had to do. and they're all dynamic and do their own thing. That is freaking awesome. So, a way to make this much easier is to use classes and object-oriented programming, and all that is basically like if you have an array of, wait, let me start this way. Classes create objects, and you can create arrays of objects, and what an object is simply variables and functions that are cluttered together, so that way you can call a variable or a function from within that object that comes from an array. That sounds complex, but trust me, when you get into it, it'll make perfect sense. So yeah, that's it for this video. Next video, I'm considering doing a Space Invaders, because, I mean, look, we already have the ability to make each ball its own sentient thing, right? So all we're missing is like a player and maybe some enemy bullets and player bullets, right? Like, but that might be hard. Yeah, that would be a little difficult. So you know what? In this video, I'm going to put a link to another video that will show us, or that will show you how to do that if you're interested, but you don't have to. And in the next video, I'm probably just going to jump straight into object-oriented programming. So feel free to go into the description and click on that link. Yeah, feel free to do that if you want to get more into how this works. This is basically the old way games were programmed. Now that we have objects, it's way easier. There is somewhat of a trade-off, but it is way easier. So yeah. Next video in this lesson series isn't going to be how to create that game. It's going to be basically object-oriented programming. So yeah, feel free to skip straight into object-oriented programming, you know, the next lesson or the next video in this lesson series. So yeah, feel free to do that if you want, and then come back to it later. There is going to be a lot of things in programming which don't make sense at first, and you look at it and you're like, but at least if you skim over it and then you start learning new things and come back to it, it'll make sense. So anyway, I will see you in the next video, and yeah, happy coding.